Welcome you all to the week 4 problem solving session of Basic Calculus 1. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. In this particular problem solving session, we primarily discuss the concept of continuity, algebra of continuity, and their main results that are intermediate value theorem, extreme value theorem, and sign preserving property. So let me first recall what is the test of continuity, or you can say continuity test. Continuity test. Can anybody recall what is continuity test? How you can check the continuity of a function?
The
Continuity.
limit the x tends to 0 minus then plus then f of that function should be equal.
Okay. So let me write it precisely. A function fx is continuous at x equal to c if and only if, first of all, f of c, tell me first of all, f of c must be defined. Define means exist. Second, limit x tends to c fx exists. Third one, limit x tends to c f of x is equal to f of c. So let me explain in informal language. First of all, the functional value. The functional value means f of c. The function must be defined at c. Secondly, the limit of this function at x tends to c must exist. And the last one is this limiting value is nothing but equal to the functional value. Is it clear? Okay. So let me write here the first question. Use the following graph and discuss the continuity of function. So the graph is as given as this is your x square minus 1 and this is minus 1, this is also minus 1, and then there is a hole here, there is a graph till this point, or in fact we may draw till this point, and then it is coming back to this one. So then this is going till this point. So this is your 2, 3, 1, and this is your 1, and this is your 2. This is the graph of the given function. Here this is y equal to 2x, this is y equal to minus 2x plus 4, and what will be this line? Y equal to
0.
0. So from this graph we need to discuss its continuity at each point. I told you the definition, recall the definition of continuity. So since we are writing it as definition, so we try to avoid this must word. So this exists. So it is if and only if function at functional value at that point exists. Secondly, limit at that point exists, and the last one is limiting value is equal to the functional value. So you need to check all of these for each point of this function. Try this one. So what is the domain of this function?
Negative 1, 3.
Sorry,
Negative 1, 3.
negative 1 to 3. Both are included.
No, sir, no, sir. The 0 not included. Negative 1 to 0.
Next,
Then open bracket 0 to 2.
next.
Then 2 to 3.
So it's very obvious. We don't need to worry what happened at 0 and what happened at 2. Is it clear to everybody? Here C means a point that belong to the domain of f. So now first of all let us cover this interval. So minus 1 to 0. What is fx? Is it a continuous function?
Sir, except at -1, it is continuous.
On minus 1 to 0. In fact, we can say at minus 1 to 0. Why I am saying that? I am talking about the points that lies in the domain. So if you talk about at x equal to minus 1, or more precisely, let me discuss here only this open interval. We will deal this case separately. So till minus 1 and 0 it's fine. Between the interval minus 1 and 0. Next 0 to 2. What is fx? 2x, which is a continuous.
Sir, 0 to 1, not 0 to 2.
Okay. So we are separating the cases for which function is dividing. Okay. So which is a continuous function on 0 to 1. Although it is a continuous function for whole real line, but we are talking only about our given particular domain. Next is 1 to 2. What is fx? 4 minus 2x. Again, it's an equation of a straight line. Continuous function on 1 to 2. Next 2 to 3. In 2 to 3 function is 0, which is continuous on 2 to 3. Now what are the points left in the domain? I am talking about the domain. X equal to minus 1, x equal to 0. Will 0 be included?
No, sir.
0 is not a point of domain, so we will not take care of it. 1. What about 2?
No, sir. 2 is not included.
What about 3?
Not included.
So we only need to talk about x equal to minus 1 and 1. Now at x equal to minus 1. If you see the lectures, you obviously know about that in case of limit what we need a neighborhood of this minus 1. You need this neighborhood, right? So that you can approach this minus 1 from the left and from the right. But this should be, in case of continuity I am telling you, this should be intersected with the domain of f. What will be the intersection? From where it will start then? Minus 1 to 1 plus delta.
Yes, sir.
So x must be from this domain. So that means we only have to take care about limit x tends to minus 1 plus fx, and first condition was f of minus 1 exists. Second is this should exist, and the last one is this right hand limit must be equal to this functional value. Is it clear?
So, sir, the minus 1 minus f of x in the limit, that does not need to be existed, right, sir?
No. In case of continuity, you don't need to check that because it's not a part of our domain. So now f of minus 1 is what is given to f of minus 1. What is f of minus 1 from the graph? Tell me.
0.
0. So obviously it is defined. Okay. So existing, or rather than we may write it point number 1. Now limit x tends to minus 1 plus fx will be equal to limit x tends to minus 1 plus of x square minus 1. One way is put x equal to minus 1 plus h. So it will be limit h tends to 0 minus 1 plus h whole square minus 1. One way is to solve this. Another way is see the graph. What you want to talk about? You want to talk about its right hand limit. So you have to approach this minus 1 from the right hand side. Then function will going to where? Which point? This one.
Yes, sir. 0.
So the value will be 0. Now third point, this right hand limit is equal to f of minus 1. So that means f is, so in short I will write continuous means CTS at x equal to minus 1. Now let us discuss the last. What is that? At x equal to 1. So first of all, what is f of 1? From the graph tell me. What is f of 1?
1.
F of 1 is 1.
1.
Second, limit x tending to 1 minus, since we have both the neighborhood, both the sides of the neighborhood in the domain, so we have to calculate explicitly what is limit 1 minus and limit 1 plus. You understood why I am dealing both the side of the limit? So now see, if you will come from this left hand side where your function is going, tell me.
2, sir. 2.
And what about right hand side of this one where your function is going?
Same.
2.
Okay, so this is also, this is 2 and this is also 2. Thus since LHL equal to RHL, that means what we can say,
Limit exists.
but limit x tending to 1 fx does not equal to f of 1. That means f is not continuous at x equal to 1. Hence f is continuous at every point of its domain except Is it clear to everybody? So now you know how to check the continuity of a function, and this continuity, since it is not continuous, so what we call it? Discontinuous at x equal to 1. Since the word discontinuity come here, what can be the type of discontinuities? Removable discontinuity. What is removable discontinuity? Anyone?
Sir, when the limit of function exists, but the function is either not, but the function is not defined at that point.
Okay. For example, limit x tends to 0, sin x by x is 1, but sin 0 by 0 is not defined. Or if we will write it like this, suppose this is your fx, and let fx is sin x by x. So then we can say that this f0 is not defined. Then this type of discontinuity is called. Is there any issue? My screen is not visible, I guess.
No, sir.
Okay. Let me just give me a second.
Okay, sir.
Is it visible now?
Yes, sir.
Okay. So f of 0 is not defined here. So what we can say, this continuity can be removed. How? You may redefine your gx, which is equal to fx, if x not equal to 0, and 1 if x equal to 0. In this case, can you say this gx is continuous everywhere? Can you say?
Yes, sir.
Is it clear? If you have any doubt, then please discuss it. Okay. Next is jump discontinuity. What is jump discontinuity? So if we will discuss from the graph, suppose your function is like this till this point, and suddenly it starts like this. So from here there is a jump from this point to this point. Is it clear what is jump discontinuity? The third one is infinite discontinuity. Infinite discontinuity means the limit is infinite. So you can take is it clear? At 0 it is a kind of infinite discontinuity. I hope I am audible to everybody.
Yes, sir.
Yes, sir.
Okay. Then the last one is oscillatory. What will be the example of oscillatory discontinuity? We have done in the
Sine 1 by
previous
x.
3 tutorial sessions.
Sine 1 by x.
Yes, sine 1 by x. So fx is sine 1 by x is greater than 0 and 0 when x is less than equal to 0. Now these are the 4 type of discontinuity, and one term is called kind of discontinuity. First discontinuity of first kind, discontinuity of second kind. Now, and this includes definition number 1 and 2, that are removable and jump discontinuity, and second kind is infinite type discontinuity and oscillatory type discontinuity. So is it clear to everybody what kind of discontinuity we have and under which category they fall in? Now let us understand this with the help of example. Examine the type of discontinuity in each function. The first one is try this one. First of all, tell me the domain of this function.
All reals except plus 2.
Sorry.
All reals except plus 2.
Okay. So is it continuous at every point?
No, discontinuous at 2.
At 2. Can we discuss its continuity at 2?
No, sir. The domain does not have it.
What about y is equal to this one? So here we know that this point does not lie in the domain of the function. So it's obvious we don't need to discuss its discontinuity, or we don't need to discuss its continuity. But to tell the type of discontinuity, we must have to think about what type of this function can be of discontinuity. So for that, you need to calculate limit x tends to 2. So what is limit x tends to 2 plus?
Infinite.
Plus or
Infinite.
minus?
Plus.
Plus infinite.
So I'm not calculating it, I'm writing it directly. Is it clear? I hope it is clear to everybody. Now 2 minus will be
Negative infinite.
negative infinite. So its limit itself is not existing. So which kind of discontinuity it may fall?
Infinite discontinuity.
Infinite discontinuity at x equal to 2. Is it clear to everybody? For infinite discontinuity, we only need at least one side of the limit is infinite. It may be right hand side or it may be left hand limit, any side of the limit. Now what about this function? And the other way around is you can solve and check. So where the function is undefined here, whenever this function is 0, our given function will be undefined. So this will be this one and 1 and 3. So in domain, can you say that this function will be cut any of the factors? So I think no. So your domain of function is again real number minus 1 and 3. Now tell me what is limit x tends to 1 plus
Infinite.
and 1 minus?
Minus infinite.
Minus infinite.
Are you sure?
Yes, sir.
What if I would say it will be also plus infinite?
Sir, at 1 plus it will be minus infinite, and at 1 minus it would be plus infinite.
Limit 1 plus it will be 2 plus h and h minus 2. So this will be minus infinite. Is it so?
Yes, sir.
And from here this will be
Plus infinite.
now what about 3?
Plus infinite.
Limit h tends to 0, 4 plus h into 2 plus h. Next 3 minus is limit h tends to 0. So from here it will be 4 minus h and what will be? So what will be the limit here?
Minus infinite, sir.
So again you got the infinite kind of discontinuity. Infinite discontinuity at x equal to 1 and 3. Now let us discuss C part. Y is equal to mod x minus 1 sin x. In the earlier cases, we have not discussed the type of excuse me, the interval on which it is continuous. Here you should discuss that on which interval your given function is continuous. Try this one. What is the interval of continuity? What is the interval of continuity? Is it fine? Anybody has objection over it?
Sir, then the range will be more than one function for the sine function, right?
So
So shouldn't we need to split the sine function like for the sine inverse function like that?
recall algebra of continuous function. When f and g are continuous on the same domain, then their addition, scalar multiplication, their division, but the division should be meaningful, their power function or composition of function, if they are meaningful, then these all are continuous. So here you know that x minus 1 is a straight line. X minus 1 is a straight line now.
Yes, sir.
It is continuous on whole R. Correct?
Yes.
Again, if I'm talking about mod of x minus 1, that means that will be the composition of mod and x minus 1. Or in other words, if I would say this will be a line like this. Like, right? Again, this is continuous. Any doubt?
No, sir.
Now, sine function. Is this the graph of sine function? Is this the graph of sine function?
No, sine 0, 0, right?
Oh, I'm sorry. I always do this. So you should tell me at that same time. Now, why did you take that much time? So is this one fine? Fine now.
Yes, sir.
So it is defined for whole R. It is continuous for whole R, na?
Yes.
Both the function are continuous for whole R. So that means their addition will be continuous on whole real line by algebra of continuity. I think you have not watched the lectures. Now y is equal to cos x divided by x. Tell me type of discontinuity or maybe continuity, interval of continuity.
Discontinuous at 0
Okay. Why?
because upper side 1 and below side 0, infinite.
So if I would say limit x tends to 0 is, will it exist
No, it is infinite.
from both the sides?
No, in the both sides, it negative infinite and infinite.
In case of cos x, the limit itself will not exist. So infinite discontinuity at x equal to 0. Moreover to that, domain of this function is r minus 0. Is it clear?
So the screen is not visual.
Sir, network issue.
Wait. Now it is visible.
Yes, sir.
Yes, sir.
Okay. So next one is find the limits, and I will let you know what is the special thing about this limits. Although we have done the limits questions in the last classes, but this is somewhat different. Sin x minus sin x. Find out this limit. Acha, tell me, is this looking a composition of two functions? Is this looking a composition of two
Yes,
functions?
sir.
Okay. There is one thing, if you will observe here, you say at the time,
Yes,
Archit,
sir.
your voice is breaking. Akshay, is it from my side network error?
No, sir, no. His voice is breaking.
Okay. So in the last, when we say function is continuous, we write like this, or we obviously claim like this, the third point. Remember?
Yes,
So
sir.
what if I will write like this? Will it the same? X is a continuous function on whole R. Akshay.
It's a second, yes, sir.
So the continuity means of any function that you are indirectly taking this limit inside of that function. That is why this is coming f of c na.
Yes.
So this is the meaning of continuity. Now here sin x is a continuous function.
Yeah.
So that means to calculate this limit, what you have to do?
Of sign of limit.
But these points, or you can say the range of this function, because this is a composition of function, f of g is well defined when the range of g must be a subset of domain of f, because how it is defined, f of g of x. How you will calculate f of g of x, f at this point? This
First G of x, then F
must
of
must
x.
be in the domain of f na.
Yes.
So since sine function has its domain whole real number, so this is a valid point. Next, sine, so it was pi. So now it, by the algebra of limits, how can you write? Or maybe the continuity or algebra of continuity, you may write it limit x tends to pi x minus limit x tends to pi sine x. Is it correct? Or any objection?
No,
Now
sir, correct.
limit x tends to pi x is pi. Why?
Because
Why?
it's only it's there.
Sorry,
It is only it's there limited
it
by.
is a continuous function. Now you know the continuity, so that means whenever the function is continuous, you can replace directly the function with that value, right?
Okay.
In the same way, tell me what is sine x? Sine pi.
Some pi.
So that means this will be sine. What is the value of sine pi?
0.
Now again, is it correct?
Yes, sir.
Now in the same way, following these algebra of continuity rules, tell me secant square of x minus 10 square of x minus 1 is equal to which value? So this is your question. Okay, try this one. Any answers?
Sir, one, sir.
1. How?
Sir, first, like in the earlier saying, we must put the limit in the inside function.
Hmm.
So at that time, the limit.
Why? First of all, what is the domain of this continuity of this function? Second function. Then only you can put it inside. Na? You should know that this function is continuous at x equal to 1. What is the domain of second function? Whole r minus. Where it is 0? Odd multiples of.
5/2.
So that means this second function is continuous at x equal to 1. Now it will be applied to this x times secant square x minus tangent square x minus 1. Now tell me, by the algebra of continuity, what you can say? Limit x tends to 1 x secant square x minus limit x tends to 1, or you have done something else.
No, sir, same.
What is 1 plus tan square x? What is 1 plus?
Sec square x.
6 square x.
So you are alive here, Archit?
Yes, sir.
You are here?
Yes, sir.
Okay. So this is x times x minus 1 secant square x. Can I write like this?
Yes, sir.
So this is the function where you have to apply by the algebra of continuity. So this will be limit x tends to 1 x minus 1 into limit x tends to 1 secant square x. So this will give you value. Both are continuous function at x equal to 1.
Yes, sir.
Yes.
So you can directly put x equal to 1 in those functions. So this will be 0
0.
and this will be.
Sec square 1.
So the answer will be secant of
Sec
0, that is
0.
1.
1.
Now the next part is limit.
Sir, can we. Hello?
Yeah, I'm hearing you.
Sir, instead of that, can we just split that in the earlier, like 6 square and tan square?
Hmm.
Then 1 by sec square, 1 by cos square, and sin square by cos square. Like
Hmm.
that formula, can we use it?
Yeah, you can do it.
Okay, sir.
Now we will do together here. So tan is a continuous function at x equal to 0,
Yes, sir.
where the function tan is not continuous. On which points?
Sir, at odd multiples of pi by 2.
Okay. So that means you can take inside this limit x tends to 0
Yes, sir.
pi by 4 cos of sine of x to the power 1 by 3. So this is a kind of constant times a function. So by algebra of continuity, what you can write?
Again, split.
Again split, or you can take out this pi by 4. You can write like this.
Yes, sir.
Now this is a composition of two functions. So cos function is again defined at pi by 4. Oh sorry, defined at x tends to 0.
Yes.
It is continuous at x tends to 0, at x equal to 0.
Cos 0 infinite, right?
Sorry.
Cos 0 infinite.
Very good. You are absolutely fine. You solve our mystery. Anyone? Cos 0 is
One,
infinite.
sir. No, sir.
Akshay.
Okay, sir.
Yeah. So limit will go inside. In the same way, your sine function will also continuous at 0.
Yes, sir.
Again it will go inside. So I am skipping one step. So it will be limit x tends to 0, x to the power 1 by 3. So this will give you 10 pi by 4 cos x to the power 1 by 3 is the continuous at x equal to 0.
Yes, sir.
So
Yes.
this will be sine 0.
0.
What is sine 0?
0.
Zero.
And cos 0 is infinite.
1.
1.
So,
Yes, sir.
10 pi by 4 is
1.
clear. Now quickly calculate this value. Cos of pi divided by 19 minus 3 secant of 2t. Quickly.
sir. Okay.
Yes, I already did that. I know where you can find out my mistakes. So cos is continuous at t equal to 0.
Yes, sir.
This is a division of two function. One is constant and one is function of t. So constant will remain as it is and the limit will apply to the
Denominator function.
in denominator. Again there is a composition of two functions, square root and 19 minus 3 secant of 2t. Again you can take limit inside.
No, sir. We cannot take limit
Why?
inside. Sir, root x is not continuous at t equal to 0. Root
Hmm.
t is not continuous.
Recall the definition of continuity.
Sir, if the limit exists and the function is defined and both are equal,
Hmm. And what is the domain of square root of t?
sir, 0 to
0 to
infinite.
infinity.
What is the neighborhood of 0?
Sir, right
0
hand
plus 1.
neighborhood.
So that means the intersection will be right hand neighborhood. So if we are talking about limit t tends to 0, that means it is quietly obvious that we are only talking about positive side. First of all. First of all. Okay. For your sake of simplicity, I am writing here plus. Okay. If I am saying I am talking about this limit t tends to 0, then I am assuming that this internal quantity must be 0. Oh, must be positive. FOG is defined when your
T is
When
susceptible
range
internal
to.
of
function
g,
is
range of
lying in the domain of f. Remember, Archit?
yes, sir. Yes, sir. Yes, sir.
So in if that is the case, then you can also say what is the range of this secant function?
Sir,
1 to
1 to
infinity.
infinite.
1 to
1 to
infinite.
infinity, yes, sir.
So that means it can be the negative function also, right? But when you are close to the 0, can it be the infinite?
No,
See,
sir.
the graph of the cos function is like this. When it is a neighborhood of 0, it will be a neighborhood of minus 1 to, sorry, a neighborhood of this 1, right?
Yes, sir.
Anyway, it will be not greater than 1. It will be any quantity that is lies near around the 1. It might be minus 0.99, minus 0.9, or it may be zero point 0.9, right?
Yes, sir.
In the whole solve scenario, this whole quantity will be positive or negative?
Sir, positive, sir. 15.9999 something.
Okay, positive. So that means t tends to 0. Is it a valid point to discuss it?
Yes, sir.
Yes,
Valid
sir.
point.
Understood? Why it is t tends to 0? So by algebra of continuity, you can directly write like this. Any doubt?
No, sir.
What is secant of 0? Infinite, Akshay.
No, sir.
This time it will be again. Tell me.
One.
-3, sir.
Three. One. Yes.
1. So this will be cos of pi by, what is cos of pi by 4?
1/√2.
Good.
√2.
So the last one regarding this algebra of continuity is under root 5 under root 3 10x. Now Akshay, you will tell me what is the answer. Archit, you may find out but you will not tell the answer. He will tell the answer first.
Sir, is it 3?
Correct. 3 is correct. So algebra of continuity allow us to put this limit x tends to pi by 6 explicitly to both the functions. 5 under root 3 limit x tends to pi by 6 10x. What is x tends to pi by 6 cosec square x is 2 square x 2 square,
4. Yes.
and this will be 10x will be under root 3. So
Sir,
this
1
will
by
be
1
root
by
3.
root 3. 1/√3.
1 by root 3. Okay, 1 by root 3. At least you know the values. 4 plus 5. This will be 3.
3.
Is it clear what is algebra of continuity means? Now I am defining a function, or you should define this g3 in a way that extends g x is equal to x square minus 9 divided by x minus 3 to be a continuous function at x equal to 3. So what is the domain of this gx?
Real number minus 3.
Real number minus 3. So it is obviously very clear what is the meaning of extension. So you know very well your function gx is not defined at x equal to 3. But if its limit exists at 3, Akshay, are you talking to me?
Sorry, sir, the mic problem. Sorry.
Okay. So I am saying its domain does not contain the point 3. But if its limit exists at 3, then the problem or the discontinuity will be the type of which kind of discontinuity? Anyone? Which kind of discontinuity will it become?
Removable discontinuity.
Removable discontinuity. That means you can explicitly define by yourself what is the functional value at G3. So that means that is the extension of function maintaining the continuity. So here, first of all, you have to calculate limit x tends to 3 of this gx, which will be limit x tends to 3. This will be x minus 3, x plus 3 divided by x minus 3. So this x minus 3 will be cancel out. Can we cancel them?
Yes, sir.
Why?
Because we didn't put the function inside.
Because we are not discussing at x equal to 3. We are discussing the neighborhood of 3, excluding 3. So we may cancel it out and we left with the limit x tends to 3, x plus 3. X plus 3 is a continuous function, correct?
Yes.
So we can directly put x equal to 3 and this will be 6. So we want our function to be continuous. So what should we G3 define so that function must be continuous?
G3 equal to 6.
And your new function can be defined in the way why should we redefine the function to be continuous? Can you rewrite your question? What is your question? Why are we redefining it, or what is the application of redefining it or making it continuous? So where are we? So we are saying that in another words we may write it as our function is x square minus 9 divided by x minus 3 if x not equal to 3, and it is 6 if x equal to 3. I am writing here fx because I have extended its version. So g3 must be 6 so that our function remains the continuous one. So the next one is define f1 in a way. Achha, tell me, in case of removable continuity you can do this, but what if there will be a different kind of discontinuity, for example jump, infinite? Can you do these things? Can you extend the functions?
No, sir.
Wait, so see, I cannot for the timing tell you the exact application of this. So everybody first of all read the comment of this one person, Shashi Kiran. इन्होंने they have asked that what should we redefine, or why are we redefining this discontinuous function to make it continuous? What is the application of this? So to be precise in mathematical way, if I would say, as I was trying to discuss, if we talk about jump discontinuity, infinite discontinuity, and the last one is oscillatory discontinuity.
Oscillatory.
So in all these kind of discontinuities, we may not extend, or most probably we cannot extend those functions to make it a continuous function. So that is the speciality of the removable discontinuity, that we can extend it to a continuous function. So exactly, if you would ask me what is the precise application, that I don't know for the timing, but in a mathematical way I can say that this is the beauty of flavor of this removable discontinuity, that it can be extended to a continuous function. Otherwise, rest of the discontinuities may not be extended to the continuous function. Is it clear? So here in these questions, they are itself hinting you that your function is discontinuous at that point and you want to make it continuous, and this can happen only in the case of removable discontinuity. So to be continuous at x equal to 4. So quickly find out what can be f of 1. What can be f of 1? See, first of all, differentiation and integration um, are not come yet, but still, if you will say after the extension, no, we cannot differentiate them. Okay, or in fact, not integrate them. In fact, in the case of, does everybody familiar with this differentiability concept? Archit, Akshay, are you familiar with this differentiability concept?
Differentiation is
Okay. See, what is the meaning of differentiation? Let me tell you first. For example, this is a curve. Differentiation means there will be a tangent, and unique tangent should be there. Okay. So for example, in the case of left hand right hand limit, what you do? You come from the left hand side, you come from the right hand side. If both the values are equal, that means your limit is existing. While if you talk about this mod of x, this is a function of mod of x. Sorry, this is a graph of mod of x. Everybody knows that. But when you discuss the continuity, as I told you, differentiability means that point must be differentiability must be there with the unique tangent. Now you try to draw the tangent from the left hand side. Where will go the tangent? Like this, from the left hand side. And while right hand side the tangent will be like this. Is it visible?
yes, sir.
So that means there will be a two tangents at 0.
Yes,
So that means the function is not differentiable
models.
at 0. So in the
That's it.
same way, for example, I am giving you the function. For example, this is a function where I am saying this is not defined at x equal to 0, and here this is the value 1. Okay, so earlier it was not defined at 0. So here your given function is x square minus 9 divided by x minus 3. So this is a rational kind of function. So this limit his limit the limit is existing, and limit is near about 6. So I am saying removable kind of continuous function is, so this is x plus 3. So its limit is existing at 6. So from both the way, this function is approaches to 6. From the whether you come left hand side, whether you come right hand side, but still the function at 3, earlier function I'm talking about, that is x square minus 9 divided by x minus 3. This x at equal to 3, will it define, or let me write like
No,
this:
sir.
x square minus 9 x minus 3, and here it is 6. If x not equal to 3, if x equal to 3, so if precisely we try to write it, so we may write it x plus 3 and 6. What is the graph of x plus 3?
Line.
This is a line which is like this. This is 3, this is minus 3. And what is 6?
A
Like this.
point. Yes.
See, in this case, you can say your function is differentiable at this point, right? But in many scenario, there might be the occurrence that this function and this function may not cut each other. For example, it will be a different point. So if you will talk about this, you can say derivative, here there will be a tangent like this, there will be a tangent like this. So for every case, can we say that your function is differentiable? Tell me.
No, sir.
Can you take the guarantee?
No, sir.
So this was all the discussion about. Now try this one.
Sir, in this question, define f of 1 or define f of 4?
Uh, Let me see. So there will be x square minus 4x plus x minus 4. So this will be x minus 4 and x plus 1. So this will be f of 4.
Sir, is this 8 by 5?
What's your answer?
8 by 5 f of x to be
I did not calculate
continuous.
it. Let Archit, sorry. Let Archit do. I did not calculate it.
Oh, okay. Sir.
Let me here mention that example explicitly. in which kind of scenario your function may be differentiable after removing this removable discontinuity. So in this scenario you can say your function is differentiable in this scenario, but when you consider your gx to be some of x sine 1 by x, where x is not 0 and 0 when x is 0, for this kind of function. So in simple language, your limit x tends to 0, x sine 1 by x is 0. Is it clear to everybody? Shashi Kiran is here.
Sir, why it's zero, not infinite?
Wait. The Shashi Kiran that have asked, maybe that person is left. So this is 0 because this is a value. Sine will give you the value, any oscillatory
Oh,
value between -1 to 1,
yes.
and it is multiplied with the 0. So
Yes.
this will be 0.
Mm.
So your function, earlier it was, if I would say, only x sine 1 by x. Earlier it was a function with removable discontinuity, and when it extended to this function, it becomes a function with continuity. Okay, so this gx is continuous function, but when you talk about differentiability, this function is not differentiable. Okay,
Okay, sir.
differentiability means the limit h tends to 0, g x plus h, and here we are talking about 0, therefore g 0 plus h minus g0 divided by h, this limit should exist. What will be the limiting value of this function will be h sine 1 by h, because 0 plus h means any function when x is not 0. What is g of 0?
0.
0.
Divided by h. So here it will become limit h tends to 0 sine 1 by h, whether this limit exists or not.
Not existing.
So that means g is not differentiable at x equal to 0. Therefore you got counter example. In earlier one you extended this removable discontinuity, but your extended function is continuous at your removable discontinuity point. Here it is differentiable, but in this case when you extend it, still it is not differentiable at that point. So that means in general you cannot say that your extended function is going to be differentiable at that removable discontinuity point or not. Is it clear now?
Yes, sir.
Sir,
Okay, so what is your answer?
8
Sir,
by 5.
So this is all
yes,
about
sir.
some extra discussion. So extension of removable. So do I need to rewrite it properly, or you are understanding with these examples?
Sir, this is enough.
Okay, so let us do this one. So your answer is also same, Archit.
Yes, sir. 8 by 5.
So let me just do for others. Limit x tending to 4. This will be x minus 4, x plus 4. Obviously this function is not defined at x equal to 4, and this will be x minus 4, x plus 1. X minus 4 will be cancelled out since x is not equal to 4 and we are moving around the neighborhood of this 4. So this will be 8 by 5 because the left functions are continuous function, and algebra of continuity allow us to put the value of x equal to 4 in the numerator and as well as in the denominator. So your g of f of 1 will be 8 by 5. So let me rewrite it like f of 1, yeah, or you can say your here we want our g function to be continuous, so g of 1 must be 8 by 5. Only in that case you can say your function is continuous at x equal to 1. Now let us do a similar kind of question for what values of b gx x bx square if x less than minus 2, if x greater than equal to minus 2 is continuous everywhere. For what values of b this function will be continuous everywhere? So that means I am telling you that you should mean the continuity of this function. So for x less than 2, gx is a continuous function.
Yes, sir. Less than 2 or minus 2.
Oh, sorry, minus 2 is a continuous function. Similarly, for x greater than minus 2, your function is b is any real number for the time being. So this will be again a continuous function
Yes.
because multiplication of any constant does not affect the continuity of the function. Now what will be the case left at x equal to minus 2? But what we know that? We know that our function should be continuous at x equal to minus 2. So your function is breaking at x equal to minus 2. That means you should maintain that limit x tends to minus 2 of gx is nothing but g of minus 2. So in other words, left hand limit of this gx must be equal to right hand limit of this gx must be equal to the functional value. Now from here, what will be the left hand limit? Limit x tends to 2 minus, it will be applying over x. Limit x tends to 2 plus, it will be applied over.
Negative 2.
Okay, sorry. Thanks, Akshay. So this will be minus 2 minus, minus 2 plus, minus 2 minus, minus 2 plus, and this is at minus 2 whole square. So this will give you, it is a continuous function. So will it matter? So we may directly substitute or we can substitute minus 2 minus h and h tends to 0. So this will give you minus 2. Is it correct?
Yes, sir.
This will give you 4b square and this will also give you 4b square. So we will not write it. So from here your b square will be, oh, why b square? Only b. Minus 2 by 4. That means minus 1 by
2.
Is it clear to everybody? Any doubt in this? Okay. Till now we have done a much calculation and understanding of discontinuity, type of discontinuity, how we can make function continuous, and how we can make and how we can fix the value of a constant to make the function continuous. But what about the lecture third in this series session is about intermediate value theorem and extreme value theorem. So what is intermediate value theorem? Can anybody tell me? in the class itself it has been discussed, intermediate value theorem. So let f is any function from AB to R be continuous, and let y naught be a point between, I hope this is clear, between, I'm writing it in the short form, FA and FB. Then there, let me write it, exists a point C in AB such that f of C equal to y naught. So I am saying here it is a continuous function. Okay, this is A, this is B. I am saying if you took any point and this is your f of A and this is your f of B. If you take any point between f of A and f of B, then there will be a point C such that f of C equal to y naught. But continuity should be there. In case of discontinuity, you cannot say that. I will also give the counter example of that. Graphically, how you can see that? For example, there is a discontinuous function. For example, like this. Okay, this is 2. This is 2. This is 1. And suppose this is 1. And this is 2. Now, if you choose any point between this 1 and 2 value, for example 1.5, can you guarantee there exists any function C for which f of C equal to this 1.5? Can you guarantee? Can you see any point for which the function will give you the 1.5 value? Can you see any value?
No, sir.
So that means continuity is necessary there. In case of continuity, you can say that because there is a no break in the function. You can guarantee. So the next question is based on this one. So you need to show that the equation x cube plus x minus 1 equal to 0 has at least one root in 0 1. Rather than one root, since it's an equation, you should say one solution. If you will write, Acha, tell me what is the difference between function and equation? What is the difference?
Equation one definite answer.
No, equation means whenever you write a function equal to 0, this is called equation. And whenever you're writing this is a function. Okay, like this.
Okay, sir.
If you will write x cube plus x minus 1, this will be a function. So function has a root. Function has a root means fx can be 0 for which value. But when you talk about equation, then equation has a solution, not a root. Okay, felt the difference? So this is the application of IVT.
Sir, is there a difference between root and solution?
Yes, I told
Sir, what
now
is the
itself.
difference?
See, if you will write fx equal to x cube plus x minus 1, you let this. Okay, if you say that function has a root, that means suppose r is a root, that means this function will be 0 at that point, right?
Yes, sir. Yes, sir.
If you are saying fx equal to 0, That means you are trying to find out the solution of this equation. That is why I said this is a function and this is a equation. Equation always have a solution, but here you are writing explicitly function, then this must has a root, then only it will be equal to 0. Root means what? For what value of this function will goes to 0?
So let's say if a function has roots which are repeated, and in the question it is asked what is the number of solution, then that repeated root will be counted or it will be not counted.
It will be counted.
It will be counted, sir.
Yeah, number of roots. See, here it is a cubic equation. Okay. So it is obviously clear cubic equation will have 3 roots.
Yes, sir. Number of roots
But
is 3.
but
But sir,
but
if
but but
number
but
of
let me
yes,
complete.
sir.
But
Yes,
if they might be a complex number, they might be a real number. Okay.
sir.
Now you ask me what you want to ask. You want
I
to
want
say
to ask
like
if
this.
in the question it is equated to 0 and number of solution is asked, and then the solution is repeating, then if number of solution is asked, we will count it as a single entity or like it is repeating all one.
2. For here there are two solutions. There are two solutions. If they will ask the distinct solution, then there will be one. Okay.
Yes, sir.
Now do this one. This is a application of IVT. How? In IVT, we are saying that for every continuous function, there will be a point where you can guarantee that that belongs to some functional value. And here, how it is an application. For example, a function give you negative value for some point, and then it becomes positive. So, can you say that it at some points it will be a 0? Can you guarantee that? Understood my question?
Yes, sir.
So I am saying that suppose this is some A and this is some B. So G of A is negative and G of B is positive. So what is IVT say? IVT say any point between G of A and G of B. So does 0 lies between G of A and G of B?
Yes, sir.
Observe, we are not saying that it is an interval because we cannot guarantee. Maybe if our function is like this, suppose our function is decreasing, then this will interval will be changed, right? If gx is equal to minus x, then for 1 2 the range will not be equal to minus 1 minus 2, it will be minus 2 to minus 1. Understood my point? That is why we wrote any point between g of a and g of b. So since 0 lies between g of a and g of b, by IVT and g is a continuous function, I am taking that hypothesis. Then by IVT, there exists C from A to B such that g of C will be what?
0.
0. In the same way, there might be a possibility that g of A might be positive and g of B will be negative. Then again you can find out a root. Think about it, any continuous function, at one point it is negative, at one point it is positive. That means it must cross that x-axis, na? if continuity should be maintained. Can you draw without drawing? I'm saying this. See, here one point it is negative, one point it is positive, and function is continuous. Can you draw without crossing this line? Can you draw it?
No, sir.
If you cannot draw it, so that means IVT give you the simplest implication that any if g of b and g of a is negative, let g is any function a b to r be continuous and g of a and g of b is negative. I'm writing negative means any one of them can be positive now, and one is negative. Product is negative when one number is positive and one number is
Negative.
Then there exists a C between A to B such that g of C will be 0. So here I am saying prove that there exists at least one solution. That means for these values you have to check one function. For one point it should be negative and one point it should be positive. So check what is f of 0,
-1.
what is f of 1.
1.
So clearly f of 0 into f of 1 is,
Negative.
so that means there exists, and observe here I am taking only guarantee of one solution. This will give you existence of only one root. I am not saying there might exist. That for that you have to find out three sign change. For example, at 0 and 1 there will be a negative, there is change of sign. Then again there will be a change of sign, again there will be a change of sign, then you can say three roots are existing. So in this case I am taking the guarantee of existence of at least one root. There might be more than one, but I can only guarantee about only one.
Sir, can we say that the number of roots will be odd?
Okay, 1 second. There exists at least one root in 0 1, or in case of one solution of x cube. What was the equation? X cube plus x minus 1 in 0 1 by IVT. Yes, now you can ask Archit what you were asking.
Sir, if f of a is negative and f of b is positive, then can we say that there will be odd number of roots between a and b?
Odd number of roots? What do you mean by that? 2 or 3 roots, 5 roots, like that?
Yes, sir. 1 root, 3 root, 5 root. Matlab, there cannot be even number of roots.
In which case, in general, you are saying f of a is negative and f of b is positive, right? That.
Yes, sir. In general.
So in general, you can guarantee about only one root. If you are saying there are 3 roots, then you have to show that by IVT specifically. I'm saying you have to show that there is a change of sign three times.
So like sir, in general, we can say that na, like if it crosses one time, there is a case it may cross only one time. But if it crosses the second time, then it has to cross third time, and if fourth, then fifth. Like there cannot be possibility that it crosses even number of times.
Here, I'm giving you that. This is the graph.
Yes,
It
sir.
started from here, it ended from to here.
But sir, here f of a and f of b both are negative.
Okay, I understood your point. It's a good point. So you are saying, okay, yes, you can say that. You want to say one is negative, one is positive, then obviously it will cross odd multiple of times. Yes, you're right. You're absolutely right. This is an intuitive idea. You can also prove it. Okay, by same manner, IVT. Okay.
But sir, I think it may not be like if it has a double root, like if it crosses first time and then it has a double root, like y equal to x square, turns like that.
Hmm, you mean like this?
Yes, sir. Like this, if it turns, then
Here, how f of a and f of b is negative or positive?
not like that, sir. In the first graph only, when it first crosses and second time it turns like this.
Okay, it first crosses.
And it turns like this. Yes, sir.
One root. Okay. So you contradict your statement yourself.
Yes, sir.
So I have to again change my answer. So it's not possible. You
Sir,
cannot
it's
get.
possible. Like now also I am not contradicted. It has three root. Now also like root is repeated, na? Three root.
Then what's the issue?
No issue. Matlab, like sir, my statement is correct, na? Odd number of roots.
See, your statement is correct, but in your statement, you have to be precise. There will be odd number of roots, but you cannot guarantee how much time it will cut your axis. For example, here it is one time it is cutting, one time it is touching.
Yes,
Okay,
sir.
but guarantee of the roots will be the same.
Yes, sir.
So whenever one point is negative, one point is positive, there will be a odd number of roots. We can say that. Okay, because I read that statement, that is why I instantly agree with you. So I don't know the proof for the time being. You can check it out. It will be like easy part of that IBT. So let's we go forward, or any other query. Archit, Archit.
No, sir.
Okay. So
Yes, sir. Clear, sir.
okay.
Yes, sir.
I think there will be a there is a network issue from your side. So I got it. So distinct real roots. So in this scenario, we have to show by IVT there are two distinct roots. So let g axis x cube minus 4x plus 1. So g of 0 will be 0 minus 0 plus 1 equal to 1. It is positive. G of 1 is 1 minus 4 plus 1. This is minus 2. This is negative. So obviously there will be a one root between 0 and 1. Since we want a distinct root, so let us move to g of 2. So this will be 8 minus 8 and plus 1, which is again 1, and it is again greater than 0. Again the difference between here. So one root is in 0 1, and one root is in 1 2. So both the intervals are different. That means there are two distinct roots between 0 to 2. Now the next one is give an example f on 0 1 such that f0 is negative and f1 is positive, but f of x equal to 0 has no solution in 0 1. So what will be the example? So we want for f of 0 to be negative, f of 1 to be positive. So it has no solution. And observe, from the IVT statement, we can guarantee about the solution if and only if the continuity is there. So indirectly, it has been asked to form a discontinuous function, because only in that case you can guarantee. So for discontinuous function, you may simply define 1 and minus 1, and 1 if your functions lie between 0 to 2, and minus 1 when your values lie between 0 to 1. Clearly, this function is like this, that 0 to half it is 1, 0 to half, okay, and half to 1 it is minus 1. So clearly there is no root or no solution of this fx equal to 0.
Sir, f of 0 is positive and f of 1 is negative. You can change, sir.
Okay, understood your point. Minus 1 and this is plus 1. So in the same way we have to change the graph. So the point is clear now.
Yes,
So,
sir.
so that means continuity plays a crucial role in the guarantee of these roots or guarantee of this IVT. You cannot ignore it. And the last question is again related to this continuity part in case of EVT, extreme value theorem. So give an example of a continuous function on 0 1 that does not attain a maximum. So by the name, can you tell me the meaning of IVT and EVT? See, IVT means intermediate value theorem. That means in the middle of that your range interval. EVT means extreme value, the corner points. So here it is saying that we can give an example where the function does not attain its maximum. Okay, so first of all, let us recall, let us construct an example. So if I define f from 0 1 to r as f of x is equal to x. So what is the range of this f?
Sir, 0 to 1.
What is the maximum value of this x?
1. Not like not, we cannot say.
So what is supremum of f?
Any real number greater than 1 or equal to 1. No, 1, sir. 1. Sir, supremum is 1.
Supremum is 1.
Yes,
So
sir.
this is the maximum value. Does it belongs to the range?
No, sir.
Why? It is not belonging to range. So you have constructed that example that it does not attain its maximum value. This is the maximum value. It is not attaining.
Yes, sir.
Here maximum means the supremum I'm talking about. Okay. Now what is EVT say? Let me write that statement. EVT say that let f a b to r is a continuous, then there exists alpha beta in AB such that f of alpha is maximum of all fx where x lies between a to b, and f of beta is minimum of all fx where x lies between a to b. So here I was saying, is it visible to screen to everyone?
Yes, sir.
So here I was saying about that continuity, but rather than continuity, the crux is the interval. Here it is a closed interval. Here it is a open
Open
interval.
interval.
So that means this interval also plays the role. So 0, 1 is not a closed interval. Hence, EVT does not fail. EVT fail when it is a closed interval and it is a continuous function, still it not attaining its maximum, but it is attaining its maximum. Okay, so that means EVT will not fail here. Okay, any doubt?
Sir, EVT will fail or it does not fail.
Here it will not fail now, because it is not a compact interval, or it is not a closed interval.
So it will fail.
It will not fail. Fail means, what do you mean by fail?
Fail means like it is not applicable. Like this is not
Applicable.
a closed interval, so we cannot apply EVT.
No, 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 no. Okay. Fail means that statement is wrong. Archit,
Yes, sir, I got it. Yes, sir, I understand.
fail means the statement is wrong. Here we are not even apply that statement, and how can you say that that is failing? Okay.
Yes, sir.
Any other doubt?
No, sir.
Okay. Then let's meet on next Tuesday.
Yes, sir.
Okay.